Now we are going to discuss extended Euclid algorithm. Okay, so any two integers a and b, s into a plus t into b is equal to GCD of a and b. So by extended Euclid algorithm, what we have to do is we have to find s, t and GCD of ab. Okay, this algorithm is similar to Euclid algorithm with a few additions. Okay, so first is same as initialization part. Initialization, that is like Euclid algorithm, n1 a assigned to n1, b assigned to n2. Okay, and few more. S1 becomes 1, s2 is 0, t1 is 0 and t2 is 1. So this is the initialization part. Okay, and then it comes to the while loop, while n1 n2 greater than 0. So it will continue here. Okay, it will continue here, and here you have to find q is equal to n1 by n2, and r is equal to n1 mod n2. Correct. See, r is equal to n1 mod n2, or what you can write. See, yesterday we have discussed a is equal to, right, q into n plus r. Correct. So here a is equal to n1, q into n2 plus r. Okay, so now r, how can you say r is equal to n1 minus q into n2? This way also you can write r. So here instead of n1 mod n2, what you can write is n1 minus q into n2. Okay, clear, right? Now the same assignment operation, that is n1 becomes n2, n2 becomes r. Okay, similarly you have to find first s is equal to s1 minus q into s2. Okay, then s1 becomes s2 and s2 becomes s. Similarly, t is equal to t1 minus q into t2, then t1 becomes t2 and t2 becomes t. Okay, so this much is there inside the loop, and this will continue till n2 becomes 0. Once n2 becomes 0, GCD is n1 and t is equal to t1, s is equal to s1. So this is how Euclid algorithm works. This you have to write and practice few times. I'll just show how to solve a few problems. Simple one I'll show first. GCD of, or a is equal to 18, b is equal to 12, or same thing. So here it's a little more big table. You have a q, n1, n2, r, then t1, s1, s2, s, t1, t2 and t. Okay, this might be enough. So first this is q, n1, n2, r, s1, s2, s, t1, t2 and t. Okay, initially n1 is 18, n2 is 12, then s1 is 1, 0, 0, 1. This is initialization. Now n2 becomes q is 1 and the remainder is 6. Correct. So s is equal to s1 minus q into s2. So that is 1 minus 1 into s2. s2 is 0, which is equal to 1. So this is equal to 1, and t is equal to t1 minus q into t2. Okay, so this is equal to t1 minus q is 1 into t2, which is equal to minus 1. So this is equal to minus 1. Clear, right? First step is clear. So now we move to second step. So this becomes n2 that is 12, this becomes 6, this becomes 0, this becomes 1, this becomes 1, this becomes minus 1. Okay, now quotient is 2 and the remainder is 0. So S is equal to S1 minus Q into S2, which is equal to minus 2, and T is equal to T1 minus Q into T2. Okay, so this is equal to 1 minus minus 2, which is equal to 3. Okay, 3. So this is Tn. Now again the next step, 6, 0, then 1, minus 2, minus 1 and 3. Okay, now when you see n2 is equal to 0, correct. Now what is GCD? GCD is equal to n1, that is 6. Okay, you are out of the loop. Now GCD is equal to 6. T is equal to T1, that is minus 1, and S is equal to S1, that is 1. So this is the answer for 18 and 12. Clear, right? Yeah. So I want you to practice few more problems. Okay, the first one, A is equal to 161 and B is equal to 28. Okay, that is actually given in textbook. You can practice that, and the assignment problems are, I am just giving the questions that is at the back of the textbook itself. That is, using extended Euclidean algorithm, you have to find the value of GCD, S and T. See, A is equal to 291 and B is equal to 42. Okay, now third is A is equal to 60 and B is equal to 400. So these 3 problems you have to do. Now Euclid algorithm also there are 2 problems, and extended Euclid algorithm there are 3 problems. Okay.